Let's look at another example for resultants and components of forces. In this case, we're going to solve something that has the resultant already. Let's look at it together. As you can see here, we've got the same T-beam bolted to the ground with two forces. F1, which is along the positive x and positive y, and F2, which is along the negative x and negative y. In this case, we know that F2 is 3 kilonewtons and it's at an angle of -15 to the x-axis. However, we do not know what F1 or the angle of F1 is. We do know, however, that the magnitude of the resultant force is 2 kilonewtons along the positive y-axis. I'm going to start off exactly the same way as we did last time. We're going to divide F1 and F2 into components. So we don't have a lot of information about F1. If I just draw F1 here, it's got a positive component in x and a positive component in y. The angle here is theta. We don't know it. So what I can say though is that in the x-axis I'm going to have F1 cos theta, and in the y-axis I'm going to have F1 sine theta. Let's now look at F2. So F2 was 3 kilonewtons with an angle of 15 in this direction, and that means that if I divide it into components, I've got a negative x component of 3 cos 15, which gives me 2.9 kilonewtons, and I've got a component here in the negative y of 3 sine 15, which if you calculate works out as 0.78 kilonewtons. The next thing I'm going to do is I am going to write out the equations for the resultant force, just like I did in the previous exercise. So Ry, the resultant in y, with this being my positive y direction, equals F1 sine theta minus 0.78. I know that the resultant in the y direction is going to be 2 kilonewtons, right? Because that is specified here in the question. The resultant force is 2 kilonewtons along the positive y-axis. So I've got plus 2 there. Okay, this is going to be my first equation. I can also write it by isolating F1 sine theta, and therefore on the right hand side I will have 2 plus 0.78, so this will be my first equation. Let's look now at the resultant in the x direction. So in the x direction I've got F1 cos theta, and then I've got minus 2.9, that's the component of force F2. Now I know that the resultant for both forces is only 2 kilonewtons along the positive y. That means that along the x-axis it has to be 0. So this equals 0, and if I move things around to isolate F1 cos theta, my second equation becomes F1 cos theta equals 2.9. Now I can see here I've got these two equations and I've got two unknowns, which means that I can solve this using simultaneous equations. The way I'm going to solve it is, and as I said before, there are loads of ways of solving everything, but I'm just going to use this. I know that tan theta is sine theta over cos theta, and if I use this equality, I can just divide equation 1 by equation 2, and that gives me F1 sine theta over F1 cos theta is going to be equal to 2.78 divided by 2.9. So I've really just divided both sides of equations 1 and 2. Now, as I said before, there are loads of different ways of solving it. This just seemed the simplest to me. If I do that, I can see that F1 it gets divided with F1. I'm left with sine theta over cos theta on this side, which, as we said before, is tan theta, and on the other side I've got 2.78 divided by 2.9, which is 0.958. And if I do inverse tan on my calculator, I get that theta is 43.78 degrees. Now that I know theta, I can go to either one of my equations, 1 or 2, plonk that in and get what F1 is. I'm just going to take that number and go to equation 1, and if I write that in, I know that F1 sine theta is 2.78, and therefore F1 is going to be 2.78 divided by sine theta, and that works out as 4.01 kilonewtons. So there we have it. I've got my angle, I've got the magnitude of force F1, and that's really all I needed to find. What I'm going to do is I'm going to do a little check, right? Because I had quite a lot going on here. I want to check. So let's do that together. And I'm just going to check by substituting everything into equation 2. Now equation 2 said that F1 cos theta equals 2.9. Let's check that that works out. So I've got 4.01 cos an angle of 43.78. And if you put that in your calculator, you will find out that that works out as 2.9. So we can tick that and assume that all is correct. And that was just how to look at exactly the same thing, dividing into components and looking at resultant forces when we actually have the result and need to find some things along the way. I hope that's helped clarify anything that was unclear until now. But now we know forces, components, and resultants, we can move on to some more structural engineering exercises. Bye for now.